All right, the next test is sort of a heavy lifter for me in the sense that, remember how I always said I always forget the limit comparison test? I always use the comparison test, which I'm not necessarily certain that I should be. I really do think I should be using that limit comparison test a little more. But let me go over the comparison test, and we'll see some situations where comparison test works even though the limit comparison test didn't. Okay, so if 0 is less than an less than bn for all n, okay, again, it could just happen at an infinite tail. Okay, by an infinite tail, I mean, like, if this, I don't really care what happens at the beginning of the series. I really just care that this happens at the end and eventually forever. Okay, then the sum of an diverges is going to imply that the sum of bn diverges. The sum of bn converges is going to imply that the sum of an converges. Okay, right? If the bigger one converges, then the smaller one's going to have to converge. If the smaller one diverges, the bigger one's going to have to diverge, right? Okay. All right, let's take a look at a couple of the ones we've already done. So let's take a look at the sum, n goes from 2 to infinity, n cubed over n to the fourth minus 1. Okay, now n to the fourth is bigger than n to the fourth minus 1, right? No, smaller than, right? So 1 over n to the fourth is bigger than 1 over n to the fourth minus 1. Correct? Okay, so when you do that, you replace it. Okay, so now this thing is less than then n goes from 2 to infinity, n cubed over n to the fourth, and this equals from 2 to infinity 1 over n, so this is divergent. Okay, now the problem is this is the bigger one. Damn, right? This is the bigger one. So the divergence here of this shouldn't really tell us anything about the divergence here. Okay, so the comparison test actually kind of failed here. Okay, that's why the limit comparison test is nice. Now, I could probably push the algebra here to make it work. Okay, there's probably some algebra, there's not probably, there is some algebra trick I could do to make it work. But why do that when our limit comparison test worked? Okay, so here the comparison test failed. Why? Our divergence series, let's put it from 2 to infinity. Okay, was bigger than the series we were comparing it to. Okay, so we don't have the proper thing. We need something over on this side. Okay. All right, let's take a look at another situation. Okay, let's take a look now at the sum, and goes from 1 to infinity, 2 plus negative 1 to the n over n to the 3 halves. Okay, now here, we're going to try first what happens with the limit comparison. Okay, we're going to try the limit comparison with 1 over n to the 3 halves. Actually, let's even do it with 3 over n to the 3 halves. You'll see why in a second, okay? Because that's what we're going to do the limit test with. I'm sorry, the comparison test with, okay? So if we do the limit comparison, we know this is a convergent series. Okay, that is a convergent series, definitely, right? P series with P greater than 1, okay? So, trying the limit comparison, we're going to see limit n goes to infinity, okay, of 2 plus negative 1 to the n over n to the 3 halves divided by 3 over n to the 3 halves. That's the limit. N goes to infinity. 2 plus negative 1 to the n over 3. That doesn't have a limit. Negative 1 to the n keeps being like plus 1. So this keeps being oscillating between 1 and 1/3. So no limit. Okay, so our limit comparison test fails. But now you see where we're going with this, I hope. 2 plus negative 1 to the n over n to the 3 halves. That's less than or equal to 3 over n to the 3 halves. By the way, it's also bigger than or equal to 1 over n to the 3 halves. Okay? Now, this converges. So our original series that we're looking at converges. Okay, now we might be tempted to try to compare it with the sum of 1 over n to the 3 halves. And that's not quite going to work because since this is convergent and it's less than the series we're comparing to, it doesn't tell us enough. Okay? It's so tempting, and there's often times when you really want that to work. It just doesn't happen. Okay? So if you want to say that it's convergent, you have to find something bigger. If you want to say that it's divergent, you have to find something smaller. I'm sure I could have done it on that one, but it wasn't worth it. Okay? All right. One more video in 8.3, and I'll see you there.